In this video, I wanted to show you a couple of other things that the determinant can be used for. So in this first problem here, it's asking you to find the area of a triangle where they give you the three vertices. Now if I were to actually draw this, we have a vertex at 0, 0, and then we have one at 3, 0, and then we have one at 3, 4. So in fact, this is a nice, simple right triangle, and you certainly could find the area without doing any fancy formulas, just your normal 1/2 base times height. And you're going to get 6 as the area here. Of course, if you did not have a right triangle, if you had some other weird triangle, it's generally a lot harder to find the area. However, using determinants, we can find it pretty nicely here. So what we're going to do is we're going to take a 3 by 3 determinant here, and you just put in your coordinates as your left two columns, and then you put a 1 in the final column here, and then you're just going to do 1/2 times that, and you're going to get the area. Now one quick little comment here is that technically when you do this you get a negative number, so if you want to make sure it's the area, just make it positive, make the absolute value of it at the end. But regardless, this is what we're going to do here. So let's find this here, be 1/2, and then if I break it down here, 0 times 0, 1, 4, 1, minus 0 times 3, 1, 3, 1, plus 1 times 3, 0, 3, 4. And that's just going to be 0, 0, and then 3 times 4 minus 3 times 0. And you see we get the same answer here. So again, this is a very quick and easy way using determinant to find the area of any triangle as long as you have the three coordinates of the vertices. Now the next thing, which is a very closely related problem, I asked you whether these 3 points are collinear. So remember what collinear means. Collinear means that they are on the same line. Whereas if they're not like this, these are, these ones are collinear. These ones would be not collinear. And of course, this could be a real hassle. You could be trying to find equations of things that would work for them. That's a lot of work. The easier way would be to go ahead and use slopes to see if they all have the same slope or not. Or we can actually use determinants here to determine the same thing. And it's actually very closely related to the previous one, because if they're not collinear, then you're going to get an area of a triangle. Whereas if they are collinear, then the triangles is essentially a trivial triangle, and there would be no area. So you just take that determinant, and if you get 0, that means they're collinear. And if you don't get 0, that means they are not collinear. And again, if I do this, I'll do it the other way here, where I copy down the 2 rows here, and then we do our 3 pluses and 3 minuses. And so then I'd have 1 times 5 times 1 plus 3 times 1 times 3 plus 1 times 2 times 7 minus 1 times 3 times 5 minus 1 times 1 times 7 minus 3 times 2 times 1. And let's see here, 5 plus 9 is 14, plus 14 is 28, 13, 6, and then we are going to get 0 here. So since the determinant is 0, means yes, they are collinear. So there's just 2 things that you can use a determinant for. And it's not just in 2 dimensions like this. You can have variations where you look in 3 dimensions, or you have like a pyramid shape here. So you can actually find all sorts of cool things using determinants. We aren't really focused on it right now, but if you are interested, feel free to search and find other cool applications here.